All right, here we go. We're on our second lesson, second lesson of the unit for statistics. So the unit or the lesson prior to this, we talked about samples in populations and how they're different. So just a quick review of that. When we're talking about populations, we're talking about, as you see here in this little graphic, that our population will be the larger group. So if we're talking about as a whole, all the students in our school, that would represent the population. If we want to survey or take a sampling of a smaller group of our population, like say just the 7th graders, the sampling we would take would be the sample, just the smaller part or the subset of the population. Once we do our random sample, which we're going to learn about today, we then make an inference about the population as a whole. So since you learned about population and sample from our previous lesson, we're now going to move on and expand on that. So let's get started with that. So in every population, when we're sampling it, we need to make sure that everyone in the population has an equal chance of being selected when we're sampling. So we're looking to have an equal chance of being selected in order for a sample to be random. So what that means is I would not just select if we're looking at a survey and it's talking about our favorite sports in 7th graders, and I'm only going to survey the girls, that is not going to be a random sample, unfortunately. A couple reasons for that. Girls typically tend to like sports that are not the same as boys. For example, football. Girls don't typically play football. So if we're only sampling girls, we would not get an accurate look at what the favorite sports are for 7th graders. Also, all of our 7th graders would not have an equal chance of being sampled because all of our 7th graders are not girls. So we would have to change our sample to make sure that it is random so that everyone has an equal chance of being chosen in order to make that inference. So let's look at the examples here. We have the senior class president would like to host an after graduation lock-in. There will be games, gifts, and food. In order to decide if people would be willing to buy tickets and attend, she's decided to conduct a survey. She's going to select 25 students to meet and give input on the prizes, food, and tickets. There's 500 members of the senior class. If she selects every 10th student as they get off the bus one morning, would that be a random sample? So if we are talking about every 10th student getting off the bus, the act of picking every 10th is random, but everyone that goes to school does not ride the bus. So everyone that's coming to school does not have an equal chance of being chosen. So this is not random. And the reason for that, as I previously stated, is because it only includes students who ride the bus. We want an accurate, random look at what's happening. The survey looks at all of the kids at the school, so we would want to make sure we're giving a chance to survey everybody. If she goes and asks the choir director to allow her to survey the choir, would that be random? I would have to say no, that would not be random either. The reason for that is because it's only going to include students who are members of the choir. Members of the choir may like different things in terms of prizes, food, and ticket prices differently than what members of other activities or other parts of the student population like. So now you're going to try it yourself. Same scenario with our senior class president conducting a survey. I want you to push pause, read numbers 3 and 4, and see if you can decide if the group she's surveying would represent a random sample from the population. So push pause and then come back to me. Okay, so number 3 says she meets with the counselor who selects every 20th student on the school roster. That would definitely be a random sample. Every student in every student has a chance of being selected. The 20th student, every 20th, gets actually chosen as part of the sample. But we're not taking out or excluding anyone. It's just randomly selected by every 20th name on the list of the entire school. Number 4, she assigns each senior a number and then randomly selects 25 numbers. If every senior got a number and then she randomly selected 25 numbers, again, we would see this as a random sample. What would make this not random is if she assigned every senior a number and then picked her friends' numbers to sample. That would not be random because she's specifically picking her friends. But if she's randomly selecting those numbers, then it is going to end up being a random sample as long as every senior got a chance to get that number. So now, once we've sampled our population, we're looking at making an inference about that. So when we're talking about population inferences, once a sample has been collected from a population, you can make an inference about the entire population. So we have an inference being made here. The inference can also be used to compare different populations and make predictions about what's going to happen. So, for example, in the scenario of the senior of the class that we were just looking at, we had the whole population, and the class president sampled a certain group of students. And the number 4, it said she assigned every senior a number and randomly selected 25 numbers. She only sampled part of that population, which was our sample. Whatever results she got as far as the prizes and the price and the food, she made an inference about the population by saying, if my sample wanted these things, since it was a random sample, then I'm going to assume that my population also wants those things. So as long as I have a random sample and it's unbiased, meaning I haven't chosen anyone in particular other than just a random selection giving everyone a chance to be chosen, as long as my sample was random, I can then make that inference and assumption about the population based on what I've learned or based on the information I've gathered. So you're going to push pause and go through and do some of these things on your own. Just kind of gauging and practicing. I know this is still new, we're learning, but I want you to give it a shot and see what you come up with, and then then you'll come back and put this together. Sorry, my dog is playing. So push pause and come right back. Okay, so here we have Eastside Middle School conducted a survey of randomly selected 6th graders to determine which elective they were most likely to participate in. And we see the results. So we have 6th grade Spanish, to determine which elective they were most likely. So 14 of our 6th graders would participate in Spanish, 20 in theater, and 6 in art. So how many students were surveyed altogether? We see that we had 14 that wanted 14 that wanted Spanish, 20 that wanted theater, and 8 that wanted art. So that gives us a total of 40 students were surveyed. Now, what percentage of students surveyed selected Spanish as their elective choice? So if we're finding a percentage, we want to find the total number of students and take how many were chosen, the number that selected Spanish, and divide it by the total. So that's going to give us 20 out of 40 selected. Not 20. 14 out of 40 total gave us the choice of Spanish as their elective. So then I would do 14 divided by 40, and that's going to give me 0.35, which is 35%. 35% of the students selected Spanish as their elective. The school is estimating that there's actually 350 students in 6th grade. If we use, if we use the sampling, how many students can be expected to sign up for art? So here's where we're going to have to set up a proportion. And when I do this, it should remind you how we did this in the past. So a ratio is representing a part of a whole. You should know that. So when we look at how many students signed up for art, we know that 6 out of 40 signed up for art or would choose art in our survey or out of our sampling. If 6 out of 40 would choose art, then we want to know how many out of the total of 350 would choose art. So I set up a proportion here. Hopefully you remember doing this. Once we set up our proportion, we're going to do cross products and set this up as an equation. So I have 40 times x is 40x, and I have 6 times 350, and I don't have a calculator, so let's see, that's 2100. I'm solving for x, so I'm going to divide by 40. X is equal to 52.5. So we're going to round that up to 53 students. So again, I took the ratio of how many students signed up for art or chose art in the sample, and then I made an inference to how many would then sign up for art out of our whole population. The whole population was 350. So 6 out of 40 chose art. How many out of 350 would choose art? So D, the school estimates that there are actually 350 students in 6th grade. 350 students in 6th grade. Using the sample, how many students can be expected to sign up for theater? Okay, so same thing that we just did, with the exception of, let's see, how many signed up for theater? We had 20, so we're going to have 20 out of 40. That's the ratio that signed up for theater. And we're going to set that equal to how many out of 350 would sign up for theater. At that point, we're going to do cross products. And 40 times x is 40x. 20 times 350. That's 7,000. 20, stop. 20 times 350 is 7,000. Divided by 40. So x equals 7,000 divided by 40 is 175 students would sign up for theater. Miguel decides to drop any elective in which there's less than 10% of the population that have signed up. Miguel says that since only 6 people signed up for art, it should be dropped. Explain why this is or is not correct. So he's saying that he wants to drop art because 10% or less of the population signed up for it. So let's see what percentage of the population signed up for art. So we know that 6 out of 40 signed up for art. So let's see, what is 6 divided by 40? I believe that's about 15%. So that's going to be 0.15. Move my decimal 2 places to the right. So 15% of the population chose art. So Miguel is not correct. Wrong. Miguel is not correct because art had 15% of the people signing up for it. Finally, we have down here, we're going to mark each of the following statements as true or false based on the data. So half of the students will select theater for their elective. That is true because 20 out of 40 of our samples selected theater. Combined, Spanish and art account for 50% of the electives. So if we look at Spanish and art, we have, Spanish and art, we have 14 and 6. So 14 plus 6 is 20. So 20 out of 40 in our sample chose Spanish and art together. So with that said, If we're looking at the combination of those two, yes, that is true. It was 50% of the results. Out of 350 students, at least 120 will sign up for Spanish. Okay, so they're giving us a proportion here. We need to solve it. So I'm going to do it right above here real quick. And let's see how many people signed up for Spanish. We had 14 for Spanish. So we know that 14 out of 40 signed up for Spanish. So would that equal 120 out of 350? So we are asking, is this true? We're going to do our cross products, which is going to give me 40 times 120. Is that equal to 14 times 350? So let's see, we have 14 times 120, 40 times 120, I'm sorry, is 4,800, and 14 times 350, 14 times 350, oh my goodness, 14 times 350 is 4,900. So those are not equal. So no, 100, at least 120. No, that would be a big false. All right, so that one was cumbersome. So there was our practice. You can always pause and go back to that with the try it yourself, especially with these, the ones here where we are doing the proportions. That gets a little iffy, but you will need to be able to write ratios of what we sampled and then set it up as a proportion to find something out about or make an inference about a population. So now you're going to proceed to the Google Slides and practice some more, and you're going to submit those for a grade. And before the end of the week, you'll need to make sure that you've gotten all your questions answered by me on the live web chat if needed, so that you can go complete the exit ticket for a grade, and that is graded on accuracy. So please let me know if you're not understanding or if you need additional help. Thank you.